All right, let's go ahead and start examining what happens when you get zero and negative exponents. We've sort of talked about it, but let's really start honing in on what this actually means. So let's first look at that. We have two methods of dividing with exponents. So one exponent is just to flat out subtract your exponents, right? So if I'm doing this here and I subtract my exponents, I'm going to end up getting x to the negative second, right? But then I also said, well, remember if you get negative exponents, it means you have more on the bottom than you do on the top. So I've asked you to also just like simplify this by expanding. So just a reminder that x to the third means x times x times x. And then on the bottom, you're going to have x times x times x times x times x, right? And if I were to ask you to simplify that, you would cancel out 3 x's because these are equal to 1, right? X divided by x, the same number divided by the same number, is 1. Now you will have a 1 here in the numerator. And if I were to rewrite that, that would be written as 1 over x squared. So it is safe to say that x to the negative second is equal to 1 over x squared. Okay? Go ahead and stop the video and do the next 3, and then come back to me and we'll talk about a conclusion. So now that you've subtracted all of the exponents, for 3 you should have gotten d to the negative fourth. For c you should have gotten c to the 0 because you just subtract the exponent, so the exponent is 0. Here you would have gotten y to the 0. When expanding it up here, this one, you expand it and you would see that d to the negative fourth is actually equal to 1 over d to the fourth. So it is safe to say that d to the negative fourth is equal to 1 over d to the fourth. And then if you take a look at expanding here, you have 3 c's. All of these c's would cancel out. So like c divided by c, c divided by c, that's all equal to 1. Same with the bottom one. Everything here, all these y's would cancel out. You would be left with 1. So you've heard this before, anything to the 0 power is 1, but now you can kind of see why. That's an example of all of your variables just completely canceled out because of division. So if you want to take a look down at the conclusion, it says negative exponents represent what? So if you look here, x to the negative second is this fraction, d to the negative fourth is this fraction. So negative exponents, they represent fractions. And then anything to the power of 0 is 1. So negative exponents represent fractions. They don't represent negative numbers. And anything to the power of 0 is 1. All right, so now if you take a look, this table here kind of supports what we just learned about negative exponents. Stop the video, read what it says right over here to the left, and then go ahead and fill in what you think the answers are to each of these questions. So if you see here, you know 3 to the third is 27, and 3 squared is 9, and then 3, and then 1. And then if you look, these are just the inverses of each other, right? If 3 to the first is 3, 3 to the negative first is 1/3, 3 to the negative second is 1/9, which is the inverse of, or the reciprocal of, 3 to the second. So really, negative exponents, they're just kind of representing the reciprocals of what that number is to each power. Let's go ahead now and take a look at the next page and let's examine some of these problems. So it's safe for us now to say that 5 to the negative second is the same as saying 1 over 5 to the second. And since 5 to the second is 25, we would say that the answer is 1 over 25. So then c to the negative first, well, that would be 1 over c to the first, but we wouldn't put that to the first. We would just write that the answer is 1 over c. So now, let's take a look now as we have a fraction over here with a negative exponent in it. So let's go ahead and take a look at p to the negative fourth. P to the negative fourth is the same as saying 1 over p to the positive fourth, right? Well, now it's being divided by m. So what we have is a complex fraction, which would be, if I simplify this, this would mean 1 over p to the fourth divided by m which we could write as m over 1. And then remember, we leave, change, flip. So we leave 1 over p to the 4th. We change the division sign to a multiplication sign, and we flip it. And so now if I multiply straight across, what I end up getting is 1 over p to the 4th m. Let's look at the next one. So next one's pretty similar, right? A to the negative second, we would rewrite that as 1 over a to the positive second. But now that is being divided by h. So we're going to do 1 over a to the second divided by h over 1, which is the same as doing 1 over a to the second times 1 over h. So my final answer would be 1 over a to the second h. Now I just want you to kind of pay attention to what happened here. How did we get from here to there? How do we get from here to there? And we're going to talk about that in just a minute. Let's do a couple more. The next one, I have negative exponents in the denominator. So what I'm going to do now is I've got 1 over, and now the fraction is in the denominator. So it's 1 over 3 squared, right? Which we could say is 1 over 1/9, which is the same as doing 1 divided by 1/9. And we flip the 1/9, so it becomes 1 times 9. So the result of this is 9. So the next one, we've got 1 over d to the 4th. But then we leave the top, we change the division sign to multiplication sign, and we flip the bottom. So now we're making it 1 over d to the 4th, or 1 times d to the 4th over 1, which would just result in d to the 4th. All right? Take a moment, stop the video, and try the next two on your own. All right, so now looking at my work here, for g, when I divide it by y to the negative first, which is 1 over y, you divide, drop, change, flip, I end up getting 3y. And here, same thing, I skipped my little division part here, but you leave, you change the division sign to multiplication, and then you flip the bottom fraction. So it ends up becoming everything's in the numerator. So now I really want you to pay attention now. I want to know, how can I get from this answer to this answer, and f to the answer, the problem to the answer, the problem to the answer, without really thinking through this. Also go back up and look at the problems above. Notice, where were all of the exponents, the negative exponents, and where did they end up, right? All of the examples in the top, they were all in the numerator, and they ended up in the denominator, right? And all of these examples that you're looking at right here, all the negative exponents are in the denominator. And where do they end up in my final answer? They end up in the numerator, but now they are positive. When we simplify negative exponents, pretty much we're just putting them on a different side of the fraction bar. So, conclusions. When a term is in the numerator with a negative exponent, the whole point of moving it is that we want it to become positive. So I'm going to say a term in the numerator with a negative exponent becomes positive in the denominator. And then a term in the denominator with a negative exponent, that becomes positive in the numerator. So basically, when we're simplifying these things, we don't want negative exponents in our final answer. We want them to become positive. So instead of doing all this crazy math, we have proven that all we have to do, if we have a negative exponent in the numerator, which I like to call the numerator the upstairs, we just move it to the denominator. We just move it downstairs and it becomes positive, right? The denominator I call downstairs. If we have something in the denominator with a negative exponent, we just move it upstairs to the numerator and it becomes positive. So let's do some examples. Now, when you do these, you only move the bases of the negative exponents and the exponent with it. So if you take a look at this one, this x to the negative second, to make this positive, I'm going to put it downstairs in the denominator. To make y to the negative fourth positive, I'm going to move that upstairs. So all I have to do with this problem is I just switch the places, right? So this answer would become y to the positive fourth over x to the positive second, and that is my most simplified version. The next one, if you take a look, you just basically are looking at your negative exponents. This guy right here is negative. He's unhappy. To make him happy, I'm going to put him downstairs and he becomes happy, right? Positive, negative, positive. So when I move this guy downstairs though, I'm now left with nothing upstairs. So what has to go up there but a 1? So this answer is going to be a fraction, 1 over x to the fifth, y to the fourth. So you have to remember when you move something, if there's nothing left upstairs, you need to put the 1 there because the number like 1/2 is very different than 2 over 1, right? We don't need 1s in the denominators because it's just dividing by 1. We do need 1s in numerators because they represent something smaller than a whole. The next one, this guy right here is negative here. The x to the fourth is quite happy, so the x to the fourth stays put. So we just move y to the negative 6 upstairs. So I just do x to the fourth, y to the positive 6. And this time we don't, again, put over 1 because that divided by 1 is still just x to the fourth, y to the 6. So I encourage you right now to go ahead and just stop the video and try D, E, and F on your own, tune back in, and see if you've gotten the right answers. Okay, let's go ahead and take a look at my answers. They're a little bit trickier than the examples that we just did, but not too much. If you take a look at D, I moved only this guy because that's the only exponent. It goes downstairs. But you already have an x down there, so you can combine those x's together by adding the exponents. That's how I got 1 over x to the ninth. Don't forget the 1 in the numerator. Now with letter E, every single term has a negative exponent on it, so you're moving everybody around. Then I noticed, once I moved everybody around, made them positive, then I noticed that I have these y's. Those y's can cancel each other out. The 7 on the bottom can cancel out 7 on the top to leave you with y squared on the top. Now, the next one, letter F. Please, please, please pay attention to this. This is a really common error that people make. If you look here, this x to the negative first, that is what gets moved. Remember, the 6 is its own little guy. It has an exponent of 1 on it. Same with the 8. The 8 is not going to the negative 8th power. The 6 and the 8 are quite happy where they're at. But the x to the 8th and the x needs to switch places. So that 6 and the 8 stay put, then you go ahead and you reduce 6/8 to 3/4, and then that x at the bottom can cancel out an x on the top to leave you with x to the 7th.